Okay, so today we'll be doing the problem of valid parenthesis. So you will be given a sequence of brackets here, and you have to say that whether the sequence of bracket is valid or not. So a sequence can be called a valid if for every open bracket we encounter a closing bracket, obviously of the same type. So if you look in the first example, so for this opening first bracket we have a closing first bracket, so we should return true. For the second example we have opening bracket, closing bracket, opening bracket, closing bracket, opening bracket, closing bracket, so this is also a valid one. For the third example you can see there is a opening bracket and there is a closing bracket, but these two brackets are not of the same type, so this is invalid case. And the fourth example we can see there is a opening bracket and there is a opening bracket again and there is a closing bracket, but here you can see this should have been a closing third bracket, but it is closing first bracket, so the brackets are not matching. So at this point only we can see that this is invalid and we should return false. And for the fifth example you can see this is also perfectly balanced, so in between the second brackets we have the first brackets and both of them have a opening and closing pair, so we have to somehow construct this. So for doing this we can maintain a stack and we'll enter the opening brackets in the stack, and whenever we encounter the closing bracket and we'll see that whether the same type of opening bracket is present in the stack or not. So if it is not present, so that means that the case is invalid or the sequence of bracket is not balanced. So let us write the code. So first we will create a stack, so stack of characters st equal to new stack, and now we should iterate through the string of characters. So this is the normal way to iterate through the string. Okay, so ch every time will have a bracket or every element, or it will have every element of the string s. So we need to first check whether we are encountering a closing bracket or not. So if we are encountering the closing bracket, we need to check whether the same type of bracket is present in the stack or not. So first of all, if my stack is empty and we have got a closing bracket, so that means our expression will be false. So in this case we'll return false. Suppose if it is not empty, then we should see whether we have got our equivalent closing bracket, sorry, opening bracket or not. So if that is equal to, okay, they're not ch, that is stack dot peak. If this is the case, then we should just pop the stack, and else if the brackets are not matching, then we should return false. So we are done with the uh, first case. So for the other two types of bracket we'll just do the same thing. So let me just copy it, so copy and paste. Okay, so I'll write else if here. and this will be for the type of bracket, and same thing, we should check whether we are getting the same opening bracket or not, otherwise we'll just return false. And for the last if else statement, we'll check whether we are encountering a closing third bracket or not, and we should see whether you have an equivalent opening bracket or not. So now we are done with if we get these three types of closing brackets. Now what if it is the opening bracket? So if it is the opening bracket, we'll just push it in the stack. So st.push, and we'll have ch. So we are done with the loop. Now suppose we are finishing the loop, and we didn't get any of this return statement. So that means either your whole thing is valid, or you have got many opening brackets but you didn't encounter any closing brackets. So here you should check whether your stack is empty or not. So at the end, when you are done with all the checking, if it is a valid, then the stack should be empty, because for every opening bracket we are getting a closing bracket, and if it is invalid, then your stack will contain some elements. So we'll check if stack is empty, then we'll return true, otherwise we'll just return false. Okay, so I think we have correctly done it. So let's run the code. Okay, so for the base case it is accepted. Let's see. Okay, so it is also accepted for all the cases. Okay, so the time and space complexity is pretty simple. We are just going through all the characters of the string once. So the time complexity is O of n, and the space complexity, obviously we are using a stack, so that will be O of n also. So if you like to suggest any other way, or if you think you have a better way, please feel free to comment in the comment section.